equation of the line passing through these two coordinates on a standard coordinate plane can be written in the form ax plus by equals c, where a, b, and c are integers with no common factor other than 1, and a is positive. Hopefully you guys recognize this form. Anyone? No. Oh. What? Semester 1, unit 2. No. Well, it is the standard form of linear equation. So if you didn't have that, write down everything I'm writing. And it should be in a different color. If it's not, hopefully someone has a highlighter. You can highlight what part is actually your correction. But that's what I'm looking for when I'm grading these and giving you points back. They should all be accurate because I gave you the answer. Yeah. Yes. Okay. So yeah, this is the standard form of a linear equation. What's the normal form of linear equations that you're used to? Y equals mx plus b. So you would need to be able to identify the slope and the y-intercept, and then you probably have to rearrange it with this in order to get the answer right for what a. So how do you find the slope between two coordinates? What is slope? Oh, they are two. How do we? I'm not moving. Okay, we're gonna keep playing around. You can play around and not stop playing around. I just don't like it. Okay, I don't like it. I see right now. Just go off. Okay, one more chance. If you have nothing nice to say, then just keep your mouth shut. All right. So again, slope. What is slope? It is rise over run. So if you want to and you have the time to, and that's the only way you know how, you could make a coordinate plane and count your rise over your run. There's also another way too. What's that other way? All right, then definitely write this down. When it's 2 points, it might be better to use this equation, y2 minus y1 over x2 minus x1, also known as rate of change, which is what slope is. Right, it's how steep the line is, how fast it's changing. So up to you. You can make a coordinate plane, graph both of these, and count your rise over run for your slope. For this, I'm just going to label one of these x1, y1, the other as x2, y2, and then plug it into this. So I have 4, because that's what I said y2 is, minus y1. What's my y1? Good. On the bottom, what did we say x2 is? And then it's going to be minus whatever x1 is, which is -5. So minus, because that's what the formula says to do, and then these happen to be negative numbers. So what happens to that double negative? So what is 4 minus a -2, or in other words, 4 plus 2? 2. Oh, cool. And then on the bottom, 3 minus a -5, or in other words, 3 plus 5. So that's my rise over my run. It's probably more likely simplified. What does 6 over 8 simplify to? Good, 3/4. This 2 goes into both. So linearly, it's y equals 3/4 x. And then how do you check for your y-intercept? What can you do? There's probably a few ways. One depends on if you like graphing better. The other one depends on if you like solving algebra problems better. No? Okay. Well, since you have 2 coordinates, what you can do is pick one of them, and it really doesn't matter which one. I'm gonna pick the 3/4 because that looks easier to work with. And I'm gonna make one of them X, one of them Y, and plug it into here. And we're basically gonna be solving for the B. So my Y would be 4. My X is 3, so you just pick one of the coordinates and plug it in for X and Y, and now we're solving for B. So what is 3/4 times 3? You can give me the fraction, that's fine. 9/4, actually, because you just multiply straight across. 3 times 3 is 9, 4 times 1 is 4, plus B. To get the B by itself, what do I need to do to the 9/4? No, that would work if this was that times B. So what else? You would subtract 9/4. Whatever you do on one side, do to the other side. Now you have probably not the best to subtract fractions, because a lot of you forget the rules for that. Let me see if the calculator is helpful at all. Okay, so 4 minus in parentheses 9 division sign 4 close parentheses equals, it gives me 1.75. Which, if it's supposed to be an integer, doesn't really help. Because integers are whole numbers, or they could be negative. They have to be non-decimal numbers. So my equation right now, let's say we just leave it as a fraction, but it would be equivalent to 1.75. In order to add or subtract fractions, what needs to be true about them? They need to have the same denominator. So if I have 4 over here, and I needed to have a denominator of 4, right now it's 4/1. What can I do to it to make the denominator 4? And whatever you do on one side, you have to do to the other side. So 4 times 4 is 16. 16/4 is equivalent to 4, is it not? All right, it is. And now that they have the same denominator, you can subtract. The denominator will stay the same. What's 16 minus 9? 7. So I'm gonna leave it like that for a second. So right now I have Y equals 3/4 X plus 7/4. Now, if I need to make it into standard form, I'm going to do something to the entire problem that will make it to where there's no fraction. Do you guys know how to get rid of any fraction? Are you sure divided? That's what you said. Well, try again, not divide, multiply by. Okay, so for this problem, if I want to make this 4 go away, I could do that by multiplying by 4. The entire problem. What's 4 times Y? 4Y. What's 4 times 3/4 X? So remember, the whole purpose of doing that is so that the 4's cancel. So then it's just 3x. What's 4 times 7/4? 7, good. Or the 4's would cancel. And then this is almost ready, but hold on. Let me see one thing. Because technically when the Y, oh wait, no, I would just have to move it to the other side. So you see how in standard form, the X and Y are on the same side? You just have to move it to the same side. And it wants A to be positive. So I would have to move this 4Y to this side. So whenever you move stuff, think, what do I need to do to make it cancel? So I have 3x minus 4y, because that's what I would have to do to make it cancel. And then to make it standard form, you'd also have to move the constant on the other side, just so you know. So then you'd have to subtract 7 on each side. So this is what it is in standard form. But the question is, what's in the A position? So what is in the A position? 3. So that would be the answer for 18. Or what is this actually? 18. Okay, good. Yeah. So remember, if you moved it like other directions, then it might mess you up. Just remember it says A has to be positive and an integer, so not a fraction. Questions on this one? Questions on other ones? 16. So this one's a good one. This same situation is in a few questions. So the situation is, to summarize, we have a county, the center of the county is here, a cell phone tower is here, Esteban's house is here, and the cell phone tower has a signal range going 10 miles in all directions. Now, this specific problem is asking the tower signal range directly above a point, AB, on the ground extends to an altitude in miles given by this function. So this is an example of function notation. A jet directly above Esteban's house, and Esteban's house is here, where the blue dot is within the tower's signal range. So what is the maximum altitude in miles of the jet? Well, it said that this function would give you that. Since this is within the 10 miles of the cell phone tower, because it just told you it is, all you have to do is plug in this for the A and this for the B into this function. Questions on that? Okay, because this is a jet is above Esteban's house, which is within the signal range. So that's what we're doing. So it goes f of 10 comma -2. And we said 10 is the A. So anywhere that there's an A in here, I'm going to plug in with a 10. And anytime you plug stuff in, what should you use? Parentheses. So far, all I did was plug in the A into this chunk. Everyone see that? 59 minus 10 squared plus 10 times 10. Now the B is supposed to be what? -2. So anywhere that there's a B, we're going to replace with -2. And also use parentheses. I have to kind of squeeze it in there. So sorry. Notice that all of our answers still have the square root symbol. So it doesn't look like we need to actually take the square root of it. We just need to simplify everything that's underneath. This is one of those situations where if you have a handheld calculator, then that's great, because then you can type it in all at once, press enter, and move on with your life. If you're stuck using this one, then you have to kind of understand your order of operations better, because it doesn't work as nicely. So in this, we have some subtraction, some exponents, some multiplying, and more of that. What comes first? So parentheses means just simplify what's inside. So I can't simplify inside parentheses anymore. So now we're on to exponents. That's what we do first. So like there's an exponent here. What's 10 squared? 10 squared. You can use your calculator for that. 100. 10 squared is 100. So I'm going to bring down this 59. We're not doing anything with it yet. The 10 squared is 100. The minus comes from already having been here. So we just do the exponents. The multiplication we'll save for the next step. We're doing all the exponents right now, like this one. What's -2 squared? 4. It should not be negative. I mean, there's a negative here, so that's why I wrote minus right here. But this part should be a positive 4, because you can never square something and get a negative. Let's see what the calculator says, but. Oh wait, hold on. See, this is why I hate this calculator. You have to put the 2. No, I don't even know how to use this one. Oh, here's the plus or minus sign for integers down here, if you're using this one. You have to press 2, make it negative, then square it, and then it gives you the right answer. So I recommend just go check one out from the bookstore and not really have to worry about that. All right, we did all the exponents. Now do all the multiplying. So this part's still going to be the same, 59 minus 100. What's 10 times 10? Good, so put plus 100, minus 4, and then what's 8 times negative 2? 8 times negative 2. Negative 16. Sorry, my pen kind of froze. Okay. Negative 16. So we did all the multiplication. So this is in the same step, by the way, multiplication and division from left to right. There's no division. Now it's adding or subtracting from left to right. They're in the same step. So just from left to right, always clear your calculator before you do anything. We're doing 59 minus 100 plus 100 minus 4 minus 16. So under the square root symbol should be 39, which matches option. Questions on that one? Yes. All right, questions on this one? Questions on others? Number 1. Okay, so all right, number 1. Juliana divided the part of a number line from 0 to 1 into sections of equal length. She plotted point M on the number line as shown. One of the following circles is shaded to represent a fraction that is equivalent. And then we're thinking of one. So how many equal sections do we have on this number line? Not 5, 4. So when you count, never like the where you have to start at, don't count that as 1. So it's really 1, 2, 3, 4 equal sections total. And where is the M at out of these 4? So the fraction that we need to see, which is shaded to match, is 3/4 of the way. So which option, let's use those test strategies. Which option can we eliminate right away? If any of them, are they all? Okay, you think you can eliminate A right away? Yeah. Okay. It's obviously not 3/4 to you. Yeah. I feel like it could be close. So if it were me, I would actually do the math for A. How many sections are in A? No. And how many of them are shaded? 2. There's 2 that are not shaded, so that means that there's 8 that are shaded, which is 0.8. What's the decimal for 3/4? 0.75. That's pretty similar. I would check A, but it's not it. Which ones are obviously not 3/4 of the way? B is not close to 3/4. It's like way less. What else can we eliminate right away? And why can we eliminate C right away? It is cut weird. What I like about C though is that all the shaded sections are next to each other. Because if we had like a circle that was shaded where it's all next to each other, does this open wedge match this one? Then that's why it's not. So between D and E, you might actually have to do math. How many sections in this one? 10. How many are shaded? Which does not match the same fraction. It doesn't match the same decimal. So that's how I check if they have the same decimal. What about this one? How many sections? 12. How many of them are shaded? And if you simplify the fraction, you can simplify it to 3/4. Or if you do 9 divided by 12 in your calculator, you also get 0.75, which is the same decimal. So that's why it's questions on this one. Questions on other ones from the practice set. Henry? 30. 30. Okay. This one, stop talking. So Molly built a dollhouse. That's a scale model floor plan for the bottom floor of the dollhouse is shown below with measurements in inches. The rooms and halls are represented by rectangles. Same situation for a few of the questions. This question says, which of the following expressions is equivalent to the expression Molly used to determine the length in inches of material she needed for the curtains? So that sounds really random. It's because you have to scroll down a bit to get some more information. Oh, that's why. So that's why I wanted you to have it on the computer so that you can do that. And now you know, make sure you check if you can scroll. But it says down here, Molly added curtains along the entire length of one of the shortest walls in the dining room. So which wall is shortest? The wall, the top or the side? Side. Okay, I agree, but let's see. Hold on. All right, so Molly added curtains along the entire length of one of the shortest walls in the dining room. To determine the length in inches of material she needed, she found the value of expression to be 3.6 times 1.05. So it wants to know which one is equivalent to the expression she used. So is it A? No, because when you multiply them, you wouldn't get the same thing. Would B make sense? No, because when you add them, you wouldn't get the same thing. Some of them we might actually have to plug in and check. But I can tell from looking at it. Is the answer E? Yeah. Okay. Because it kind of reminds me of growth formula, like when we did those, where the parentheses could be 1 plus whatever the rate was. That's what it reminds me of. Because 1 plus 0.05 is what? Which matches what's over here. And the 3.6 is already there to begin with. So you're just picking which one's equivalent to what she did, and what she did is in all right, we might have time for one more. Any? Remember, you're turning this in right now. The last call. Yes? No?
No, that's.
Okay, which one?
33.
33. Okay, so we have, guys, I just need your attention for like a little bit longer, and then you can talk and move around. But if we can't get through this, I'm going to keep you in here until we do. So, of the plane figures shown below, select all, meaning there could be more than one answer. Doesn't have to be more than one answer, but there can be. Select all and only those figures that can be constructed using the lines formed by the intersection of the faces of a cube, such as the one below and a plane passing through the cube. So the answer to this one was multiple cases, wasn't it? It was the. So, I need to refresh myself on my on. So, let me look on here. So this will be available to you, but not today. Oh, and I can explain it. Okay, so select the only figures that can be used using the line formed by the intersection of faces of the cube, such as the one passing through the cube. So if I deconstructed a cube, how many squares would there be? There'd be 6. So probably something that looks like this. Right? So only these can be made using some fragment of this. I don't know how you why is a triangle? Can you explain that one, please?
There's a flat plane you're passing over the.
Okay, well, that makes sense. And then this one, the triangle.
Very good.
Triangle.